Hey guys, so this lesson's super important. It's completely new and it is very important that we get to the end of it. That's where the really important stuff is. So we are talking about linear functions. So remember that we've been talking about functions, and the definition of a function you should know. So pause the video and recall the definition of a function even if you have to look it up. Okay, so you should know the definition of a function is when a x value has only one y value assigned to it. So each domain value, each x value has only one y value assigned to it. It can't have multiple y values. Today we're doing linear functions. So it's an even more important, more special version of a function. So a function whose graph is a straight line is called just what we just said, a linear function. The related function can be written as a linear equation. So we're going to talk about how to write things like a linear equation later. And a related function is just saying we can write it like f of x something. So identifying a linear function from a graph. So based on this definition that we know what a function is and we know what linear means, it's in a line, hello, we're going to pick which one of these is a linear function, which one is just a function, and which one is not a function at all. So go ahead and pause the video right now, and you're going to pick which one of those. So pause the video now. Okay, welcome back. So we have our things down already. So if you see here, this is a linear function. Notice that it is a line, hello, line, linear, and each x value has only one y value. There's none where it overlaps. This one is a function, but it is not linear, so it's just a function, not linear. So notice that each x value again has only one y value assigned to it. None of the x's have multiple y's. And then this bottom one down here, the oval, is not a function at all. It's not a function because if we look here, this x value where my arrow is at, if I go up and down the vertical line test, it passes multiple y values. So if I did my vertical line test, this is not a function. Okay, so let's move on then. So linear functions, the way that we can tell they're linear if we don't have a graph is that they have a steady or a constant rate of change. So what this means is that the constant change in y corresponds to a constant change in x, or a steady change in y corresponds to a steady change in x. It does not mean that your change in y is the same as your change in x, but it does mean that it is constant or steady, that it's the same each time, that the rate of change is not changing. It's the same rate of change. So we have two examples here that we're going to do to identify if this linear functions, and they're just based off the points, either the ordered pairs or a table that has your x and y values. And we're going to determine whether these have a steady or a constant change in y with a constant change in x. So first we're going to draw these 3 points and put them into a table. So go ahead and pause it and put those in a table. We have our values in our table now. So notice I just put my x, -3, my y, 5, -2 with 8, and -1 with 12. So we are going to check whether we have a steady or a constant rate of change. So this is very important. You find a steady rate or a constant rate if it is linear. So if we look here, what is the change between 5 and 8? Well, the change between 5 and 8, you should know, is plus 3. So our rate of change here would have been plus 3. So what is the change then between 8 and 12? The change between 8 and 12, we should be able to tell 8 plus 4 is 12. So our rate of change here is 4. Now, we still don't know whether this is a function, linear function or not, because we have to check the rate of change in the x. So here we see that from -3 to -2, we have to go plus 1, because -3 to -2 got bigger by 1. -2 to -1 went plus 1. So if we look here, when we were going up 3 on y, we went up 1 on x. But then we went up 4 on y, well, we still went up 1 on x. So was this steady or constant rate of change? 3 is to 1 the way 4 is to 1. No. So this is not linear. So this rate of change is not, oh my goodness, this isn't working, not linear. So go ahead and watch the next video to check the next one and then look at some other really important things.